And so as you work on these here, I'm going to sort of work, I hope, a little behind you so you can kind of check your work. So you can kind of check your work as you go. So just start working on these, all right? Starting on 35 on down. And as always, I suggest on these doing a calculus rewrite for them. Like for 35. Get my skinny pen here. 35, I recommend rewriting this as -3/2 x to the -1/2. So this is what I got for number 35. So do you have any questions on 35 or 36? Okay, for number 37, this is the rewrite I have here for this one. I don't know if that's what you got for your rewrite. And then after you have your rewrite, then taking the derivative. Do you have any questions about the rewrite at all? And again, these things here, I've done a lot of these today so far, and I could have been wrong on at least one of these things. I'm usually not, but sometimes I am. take attendance with you guys. So Hannah, how are you doing on this?
I did the 37, or are we talking about the other?
37 or any of them? Take attendance on these guys. Good. So we got for this one, f prime of x is going to be equal, I got 12x to the third power plus 3 times -1 x to the -2 power minus 5 halves x to the 3 halves, and finally plus 2/7 times -1/3 x to the -4/3, and then let's see, what do we have here? Yeah, that's all of it, right? So f prime of x is equal to 12x cubed, and then that's going to be minus 3 over x squared minus five halves, or I get square root of x cubed. And then the last one here is a bit of a monstrosity. So we get this, looks like minus 2 over 21 cube root of x to the 4th. Is that right? Help me out, is that right? Is that what you got?
Looks like it.
Something, because here it is, it's like 2 over 21, so I think that's right. And and to me, the two main things are being able to go between rational and radical numbers, expressions, and also the power rule of differentiation. So really that's it. And any questions on these? Are you able to do these in your sleep pretty well?
Oh, for sure.
Or your nightmare? If you fall asleep in the class? So Hannah, you just learn by osmosis? You just turn your head, you just absorb the calculus, is that what you do? Okay, let me go.
Mr. Durham, I have
Yes,
a
sir.
question, not specifically about like one of the questions here, but like, and like if, like what would this be like used, like let's say in like a job or like a profession, like where would this be used a lot, just out of curiosity?
Yeah, here's what I've noticed in my use of calculus, which in my profession, I haven't really gone into detail like this, because when I used calculus, I didn't do these things. What I did is I used an oil and gas profession, where you'd have a production curve, and you'd find the area under the curve, which would be the amount of oil or gas produced, okay? And so basically what we're doing here is you're sort of developing your mechanical aptitude and skills, and so you're sort of building onto the train of your skills and abilities. This is kind of algebra skills when you look at it, the manipulation from radical to rational. And so I can't really point to, at least in my experience, where I've used something with this level of detail, but it's part of the overall body of work of the brain that you're constructing, that is the mathematical analytical brain. And so that's the best way I can explain what we're doing now. And so you're sort of becoming a machine, if you want to call it this way. And you can see that the skills from radical to rational, you've actually seen them before this class in some way, shape, or form, right? And so you're just building your expertise generally. And at some point, would you be able to use this in a profession somewhere? Maybe. But I haven't seen it in mine, even though I had a very highly technical profession. So the profession where I most use what we're doing this right now is my current profession as a mathematics teacher. I don't know if that was very helpful to you.
It was just out of curiosity.
No, it's fine, it's fair. Because every time, because we're doing things, and all the things we do come from the place of the real world at some point, but where we go and take them back to it, you just have to look at it. Now, if you're going into mechanical or some kind of engineering where you need to do you might be doing some integration. But a lot of the things that we do here at this level, our brains are doing it, but there are machines that do a lot of this right now for us if you do this professionally. And so what is ultimately more important than the mechanics of knowing how to do this? What is more important than that? That's my question to you right now. Yes?
Being able to apply what you know.
That's right. What it is being able to recognize when it's appropriate to take a derivative to find the slope of something. And then once you know, so what happens is the world is increasingly giving more value to the thinker and the planner, the one who decides when to apply what. And then the mechanics of these are worked out by machines that our predecessors and our contemporaries will design through artificial intelligence and information technology to do that. But what's going to happen is you guys, if you know how to do this well, you're the ones that can write the programs to do this kind of stuff, because there's a lot of industry and profit and benefit to be had from that too. Can you write a program that can do all this? Yeah, you could. You could write a program to do all this. What I want to do is go right to the product rule. That was a really good question. So we're going to go to the product rule, and we have the product of two differentiable functions. In this case, they give you a u and a v. If you take the derivative of this product, it's going to be one of the factors times the derivative of the other factor plus the other factor times the derivative of the other factor. And so this is sort of a guide, and I'm going to show you a graphic organizer that's going to help you figure out how to do these, I hope, pretty efficiently. So right now in this question, number 3, you have the table below, r of x and t of x are differentiable functions. Find the equation for the line tangent to q of x at x equals -3 if q of x equals rx times t of x. So here you're given the clue of what? This is a product of two functions. And we are trying to find an equation for the line tangent to q of x, and q of x is the product of these two functions, where x equals -3. So what things are you going to need to create a tangent line? Or a line?
Slope and a point.
A slope and a point. Okay, so slope and a point. Well, do we have any of this information here?
I don't know.
I call these tables where you have these kinds of things, I call them scavenger hunts. Because you have all this information, and so you have to sort through and do the scavenger hunt to come up with the stuff, basically. So what do we need to come up with here?
Sorry. He wants the girl with the long nails to open the soda. If that makes sense.
The scavenger. That sounds like a recipe for a broken fingernail to me. Okay, what do we put in here?
Scavenger hunt.
Yeah, scavenger hunt. The hunters haven't found me anything yet.
Oh, no, I'm looking at this.
Two.
Okay.
-3.
Where's -3 go, Gavin? About right
Oh, it's
here?
X coordinate. Ah, you silly.
Right here, okay, very good. Good job, good job. Okay, now do we have a y coordinate here?
Not yet.
Yeah.
Find me a y coordinate and then we'll worry about the slope. Let's get the y coordinate first here.
I'm gonna go with.
-8.
-8?
Maybe.
-8,
Because
okay.
if you're multiplying that.
Yeah, so you have the product of these two functions
Good job,
here.
Hannah.
So if you multiply these two together, you'll get this y coordinate here, okay? Now, for the slope, where are you going to have to go? You're going to have to go back to this thing right here that we talked about right here,
Oh, it's like fun.
okay? And I'm going to show you a little guide to do that too. But what are you going to get for that?
God.
We'll see if you can figure it out. Then I'll show you kind of a guide that's going to help you with that, I hope. Okay, you got a slope here for this set?
I'm working on it, Mr. G.
Okay, I want you other guys look like you're working on it. I will say that for you. Well, I'll just tell you what I think it is, and you tell me if. Then does anybody have it yet? I'll tell you what I think it is. I think it's negative 16. Does that look like that's
Oh,
right?
you know what I did wrong?
What?
I figured it out, don't worry.
Okay, I think negative 16 is it.
That's what yeah.
That's what you get now?
'Cause
Okay.
I had them mixed up.
Figure out, did you,
I did R of X times R prime of X, and
Okay.
so I fixed it.
did you figure out how I got negative 16?
Negative 4 times 4.
Got him.
No, I'll show you. Okay. Yes, you got it? Yes, Carson.
Sorry, I'm
Stretching, okay. Let me show you a way, kind of a graphical organizer that helps with this, that I found. So what you do is create a box like this. In the box, what you do is you put U, U prime, V, V prime, right? And what that is, that's mirrored off of this thing right here, okay? So you make this box, and what you have is you say, okay, well, this R is going to be my U, and my U prime is going to be this R prime over here. So that negative 4 goes here, and negative 2 goes here. You see that? And then you do the V prime, and what goes here? 2 and 3. Okay, and then what you do is it's going to be, you multiply these two together plus these two. And so you get negative 12, do you see that? Plus negative 4. And then that's how you come up with negative 16. And so my recommendation is when you have a problem like this, and you're going to have a lot of them from here on out, just set up your little box and just write them out, and you just multiply across the diagonals like this and add them together, and that's it. That's your slope. And so the reason I could do this in my head, well, I have experience of course, but I was thinking, okay, it's going to be this, it's going to be this times this plus this times this, right? So that's how I got it. And so what is the equation of the tangent line?
Y plus 8.
Okay.
You wrote Y yourself. You wrote Y.
Plus 3.
3. So this will be our equation of our tangent line. Okay, this is one of the things that I know hitting you with a table like this might seem sort of out of the blue, but I hope you can see that this is that you can put together and synthesize what we've learned already to be able to do this. At least that's the idea, right? Okay, let's move on here to the quotient rule. Okay, the quotient rule, and there's another device. Here's the quotient rule, and there's another device for remembering, and it's related to this, and there's actually a song for this. I'm going to see if I can remember it. I can remember it.
I knew I saw that guitar case open. I knew it was coming.
Well, actually, I had that open for another class,
Oh,
but that was...
I got this. Oh.
Yeah, I hope I remember the chords.
Hit me.
Lordy, 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 hi. You have to sing with me. Lordy, 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 hi. Lordy, 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 hi. Mine is high, high, low.
Mine's hidey, hidey, low.
all over low square. Loady, 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 high,
Loady, 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 high.
minus hidey, hidey, low,
Minus hidey, hidey, low.
all over low square.
Sure.
Let's sing it again.
On YouTube.
Loady, 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 high,
Loady, 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 high.
minus hidey, hidey, low, Carson,
Minus
sing.
hidey, hidey, low.
All over low square.
That's nice.
Okay, that's it.
That was a good melody right there, Mr. G.
Yeah, thanks. Let's come along. Former calculus teacher, mentor, partner, Miss Tracy Etheridge helped me with that one. So that was anyway. But this is one of those. It's a really, if you think about it, it can really be helpful to remember. So low-d high minus high-d low all over low squared. And we're going to go ahead and work this out using the product rule. But what you have is between the product rule and quotient rule together, you have in your toolbox additional weapons for your mathematics. Yes, that's right, Aaron. The weapons in your arsenal is what they are. Your diagnostic arsenal. And so here we have, remember, it's low d high minus high d low all over low squared. And what I recommend is also like the other one, where you just go high, d high, low, d low, and you just go ahead and write these out, what they are. And your high, you see, is t squared. And what is your d high? No? What is your d? What is your derivative of high?
Oh, that'd be 2t.
2t, okay? And your low is this one here, right? 3t squared, whoops, minus 2t plus 1, and what is your d low?
That'd be 6
6t minus 2.
minus 2. Okay.
So now you want to find v prime of t, and v of t, sometimes you'll see this called for velocity, and it just happens, v of t, velocity with respect to time. And so v prime of t, you'll sometimes say is acceleration. The first derivative of velocity is v prime of t. And for this, v prime of t is equal to low d high. So you take the low, which is 3t squared minus 2t plus 1, d high, and here's your d high, minus high, well, here's your high, which is t squared, d low. So 6t minus 2, it's all over low squared. I was, years ago, I was teaching this course, and I went to a football playoff game the night before.
And that's supposed to be squared?
It's supposed to be squared, thank you, Aaron.
Low squared.
Low squared, right. And what happened is the referee made a terrible call, playoff game, like what it was, didn't call pass interference when it was just a mugging at midfield. Okay, and so I yelled at the referee straight for about 10 minutes. And so what happened is the next day I came to work and I had this beautiful low voice with my loosened vocal cords. I could really sing this. So I sang this song great with the low squared, really low. So now, so really all you have now is simplification on top. That's it. Usually when you do this, you have the low. Usually you'll just leave this low in place like this. So really it's a matter of simplifying on top is the way it goes. So now you have like 6 t cubed, right?
Yes.
Minus 4 t squared plus 2t, and then you have minus, that looks like 6t cubed, right? And then that's going to be plus t squared, and then this will go away here, right? And so you're going to be left with, is that negative 3t squared? Because negative 4 plus 1 plus 2t. And occasionally you'll get lucky, if that's what you want to call it, and be able to factor something out to cancel, but usually not. So this is going to be the best we can do on this. So again, you'll be able to simplify the numerator usually, but the denominator, you're just going to be stuck with that low squared thing, okay? So that's where that low comes from. But does this look very hard? You think, Hannah, does that look hard? This shouldn't be that hard.
Definitely needs some practice.
That's right. Well, that's what we have. That's what we do. We practice. We get introduced to the concept, and we'll practice on it. Okay. Questions on this? Okay. Let's go on to. We're gonna have an assemblage of exercises on these soon. So here, what happened is from last year. I want you to go ahead and finish this out. What is the instantaneous rate of change? So happened I did this from last year. So I want you to go ahead and do problem 2. Finish that, because I actually did work this for you that far.
Oh, no, dude.
So it looks like here I'm getting 2 over 1. So is that 2? Is that what you got for that one? 2 squared minus 2 times 2 plus 2. Does that look right? Help me out here, is that right?
I don't know, so-
Carson's nodding his head. Carson, did you get anything else
I
besides
see
that?
what I did wrong.
So you got something different in
I
there?
moved it, yeah.
Yeah, I just,
You made
I put a
a,
negative minus 2 instead of a plus 2, so yeah, that's,
you made an arithmetic error.
that's
Okay.
what I got.
Easy to do, okay?
After a quick check.
Yeah, so, I mean, that's the kind of problem, that's a typical, pretty easy problem. One thing you can do in this, I went and worked and substituted. One thing you can do, and it's almost as easy for you to do, is you could go ahead and substitute in 2 right up here, can't you? If you substitute in 2, it might actually be easier, because then you'll have 2 minus 1, you'll have 1 times, that'll be 4, minus 2 times that. So you'll have 4 minus 2 up here, divided by 1. So sometimes you can substitute up here too, just once you have something. Okay, let's see. Let's see what we have here. Here we have find dsdt, which I don't think is product rule or quotient rule. So here's what I want to do. Work this one right here, and we will call this class for today, okay?